Hello. The purpose of this video is to review how to solve stoichiometry problems that involve gases. As you know, every stoichiometry problem begins with a balanced chemical equation. For example, 2a plus b reacts to form 3c. And you know that every stoichiometry problem has the same basic form. Given a certain quantity of a, what quantity of b do I need to use it up completely, and what quantity of c will be produced? Or, in reverse, if I want to end up with a certain quantity of c, what quantities of a and b do I need? Now, the way that we solve this for any stoichiometry problem is the same. We start by taking whatever the quantity of A is, and we convert that into moles of A. The second step of any stoichiometry problem is using a mole ratio to go from moles of one component, say A, to moles of the other component B. And then in the final step, we convert moles of B into whatever the quantity of B is that we're measuring. Earlier in the year, we learned how to do this when our reactants and products were all in the solid state. We measure out the initial quantity in terms of the mass in grams, we convert to moles by dividing by the molar mass, multiply by the mole ratio, and then convert from moles to grams by multiplying by the molar mass. But what happens if our reactants and products are gases instead of solids? Well, there are two types of gas stoichiometry problems. The first one I'll call a volume-to-volume problem, and here's an example. I'll begin with a balanced chemical equation. Ethane gas reacts with oxygen to form carbon dioxide gas and water vapor. In an assessment, you would probably be expected to balance the equation, but in the interest of time, I'm just giving you the balanced equation. So the problem would look something like this. What volume of oxygen gas would I need to completely react with a given volume of ethane gas at constant temperature and pressure? And correspondingly, what volumes of carbon dioxide gas and water vapor will be formed by complete reaction of 10 liters of ethane gas at a constant temperature and pressure? Well, how do we approach this? Well, I'll begin with a general idea that we start with the ideal gas law, PV equals nRT, and we ask ourselves, what's the relationship between volume of gases and moles of gas? Well, I can rearrange to get volume equals moles times RT over P. What this shows me is that if the temperature and pressure are being held constant, volume and moles are directly proportional to one another. So what that means is, instead of using a mole ratio, like I did before, I will simply use what's called a volume ratio. And a volume ratio tells you how the volumes of gases are related to each other at constant temperature and pressure. You don't need to know the temperature and pressure, you simply need to know that it's constant, okay? And the beauty of it is that the volume ratios have exactly the same numerical values as the mole ratio. They simply have units of volume instead. So to solve the problem, I'll take my 10.0 liters of ethane gas, and I'll multiply by a volume ratio of 7 liters of oxygen for every 2 liters of ethane gas to give me the volume of oxygen needed, 35.0 liters of O2. I'll do the same thing to calculate the volumes of products produced, 10.0 liters of ethane times 4 liters of carbon dioxide for every 2 liters of ethane to give me 20.0 liters of carbon dioxide produced, and finally take the 10 liters of ethane that I'm starting with and multiply that by a volume ratio, 6 liters of water vapor for every 2 liters of ethane to give me 30.0 liters of water vapor. So starting with 10 liters of ethane, I need 35.0 liters of oxygen to react with it, and I expect to get 20.0 liters of carbon dioxide and 30.0 liters of water vapor. Really, this is the easiest type of stoichiometry problem you're going to see. Simply take the volume you're given and multiply by the volume ratio. Remember, this only works when you're comparing gaseous reactants and products at constant temperature and pressure. Well, what if you have a reaction that involves both gases and solids? A little bit more complicated, but not that difficult. I call that a mass-to-volume problem, and here's an example. I give you a certain mass of chromium, and I ask, what volume of oxygen gas at a specified temperature and pressure do I need to completely react with that amount of chromium? Well, I cannot use a volume ratio in this situation because chromium is not a gas. Volume ratios only work when you're comparing gases at constant temperature and pressure. So let's do a little roadmap to see how we're going to progress here. Clearly, the initial quantity we're given is the mass of chromium. The only thing we can convert that into is moles of chromium. Given the fact that my ultimate answer is what quantity of oxygen gas do I need, clearly the next step is to convert from moles of chromium to moles of oxygen, and I'll do that by using a mole ratio. Finally, I'm going to convert from moles of oxygen to volume of oxygen by using the ideal gas law with the temperature and pressure that are given. So, let's begin. I'll combine the first two steps in a single operation to calculate the moles of oxygen needed. So I'll take my 20.0 grams chromium, convert that to moles of chromium by dividing by the molar mass, multiply that by the mole ratio, 3 moles of O2 needed for every 4 moles of chromium I'm starting with, and that gives me a value of 0.28846 moles of O2 needed, which essentially is N in the ideal gas law. So to finish the problem, to calculate the volume, I'll rearrange the ideal gas law. Volume equals nRT over P. In place of N, I'll insert the moles of oxygen I just calculated I need, 0.28846 moles, times the gas constant, 0.08206 liter atmospheres per mole Kelvin, times my temperature of 312 Kelvin, divided by the pressure of 1.50 atmospheres. That gives me a volume of 4.92 liters of O2 needed. Not that hard. In this case, I started with a certain mass of a solid and I calculated the volume of gas needed. I could have gone in the opposite direction. I could have specified the volume of gas at a certain temperature and pressure and asked you to calculate the mass of solid needed. You would simply go in the reverse. Use the ideal gas law to convert from volume to moles to moles with a mole ratio, and then convert to mass with a molar mass. Okay? Not that hard. That's all for today. Good luck.